Hey, Paul, we're going to start live stream. Good to go, I guess. I didn't know this is being live streamed. I guess this is being live streamed, everybody. Don't be shy if you're still trying to come on in. There's still a couple of spaces. Scooch down, make some room. I have to first of all offer some congratulations. I hear New Zealand once again beat Oracle, Team USA in sailing. Yay. Congratulations. I'm here to talk about storage. I have 60 minutes to try to cram in days worth of content on storage. And so it's kind of interesting with the schedule. They actually put the storage overview of everything new in storage after this one. This one's the deeper dive just on storage spaces and what we're doing in storage spaces. And so I'm only going to be focusing in really on one type of technology that encompasses storage. It's funny, did anyone go to Ben Armstrong's talk earlier today on virtualization at all? Anybody? A couple of you did. I don't know if he mentioned it in that one or the one coming up after this, where he talks about, he's the guy that's the product manager about virtualization, and he actually goes and talks more about storage with customers because of the revolutionary changes that are in storage that are enabled and can be lit up using virtualization with a storage backend. Storage, I was always told as a joke on the side last year at 2012, that storage is that fire-breathing dragon feature that doesn't get as much love and as much play in the press, if you will, for changes that have taken place with SMB3. And that's just, again, one piece of the storage puzzle. So without any further ado, my name is Rick Claus. I'm a Senior Technical Evangelist at Microsoft. I'm known as the guy with the green hat. You're welcome to find me and ask me questions at any time during the conference, whatever it is. Catch me online on Twitter at @RicksterCDN. If you'd like to have all my other coordinates, there's a web page you can go to about.me/RickClaus. I'm a storage geek. I'm a server hugger. I love servers. I love storage. I love SANs. I love the ways that you're able to offer services and solutions to your customers and your clients inside your organizations using storage. And so that's what we're here to talk about today. And in fact, if you think about some of the things that we had brought down and are talking about with Server 2012, it's really weird with this. I have to look up over top of everything. Some storage platform design challenges that we're basically faced with. You guys are faced with it right now. Who here has a SAN in their environment right now? Anybody? Of course, almost all of you do. Who here that has a SAN has outgrown their SAN and needs to buy another SAN? Hopefully it's the same vendor. Hopefully it's the same revision. Hopefully it's the same architecture. Hopefully you can manage it the same console. Ooh, no, sorry, you can't. It's a different console to manage it. Maybe it's a different vendor that happens to have a better offering right now for your price point range. Now you have two different ways of managing storage, the resource that's the most consumed. I like to equate storage to my recent move. In case you can't tell from my accent, I'm Canadian, not American, Canadian. And I moved from Canada to the States, and I went from a 2,100 square foot house to a 4,100 square foot rental house. 3-car garage. I only have 1 car. And the rest of it is full of stuff. And that is my SAN. My garage is basically representative of what your SANs are like. No matter how big your garage is, it'll be full of stuff. No matter what you do, you have to purge it all the time, you have to clean it up, you have to maintain it, you have to make more room for it. The same thing. If I own the house, which I don't, I could build on a separate storage and maybe have a storage shed to complement my storage inside my garage. But I would still have to have more and more space. It's also like a closet, too, same deal. So that's the analogy you've got. Basically, you've got a massive amount of data that's out there that you're working with right now, and you need to be able to serve it up the best way possible to your applications that consume it and also to your consumers, your users that use it as well. And so the idea is that we brought these learnings in from the way that we run our infrastructure as a service solutions, our platform as a service solutions up on Azure, our software as a service solutions up on Azure, and up in the cloud and our public cloud. And we've brought these learnings into our local environment. If you weren't in my kickoff session talking about Server 2012, I basically kind of asked the question pretty simple: how many SANs are in Azure? How many SANs are in Gmail? How many SANs are part of AWS? The answer is none. There are no SANs up on the cloud. It's too expensive. It's too prohibitive to manage at scale. Too terrifyingly complex to be able to try to manage across all those different nodes for redundancy purposes and different data center purposes. We don't use them in the cloud. So we brought our learnings from there into the storage environment on the on-prem solution of Server 2012. It absolutely has to be cost-effective to meet your budgeting requirements. At a recent conference I was at, they had a hands-on lab area where they could spin up 650 instances of labs to be able to have a hands-on experience. It was all done on-prem. Customer showcase, fantastic hardware. I was drooling with all the blinking lights. It was absolutely gorgeous. You could spin up VMs that were like 15 VMs in one particular lab or 6 VMs, and everyone could spin them all up at the same time. Do you know how much that thing cost? Just guess. 650 simultaneous users connecting up to a solution that can spin up 15 VMs for an environment in less than 2 minutes. Anybody? 2 mil, 100 grand, $5.1 million for that solution. How much of that was storage related? $4.8 million was storage related. The rest of it was software and infrastructure to be able to run it. So storage is a very big line item inside your budget, and being able to control that and work in a cost-effective manner can definitely earn you some points when it comes to budget renewal time. Now, the next thing is, even if you're trying to save money on storage, it's one of your most important resources out there, right? So you can't just skimp on using everyday stuff. So you still have to have enterprise capabilities, but you still have to have some level of handling resiliency, handle failure. The idea is designing something that you know is going to fail, so that way you have a backup plan to be able to ensure that you're able to work around that failure on a regular basis. And then finally, being able to go in and obviously minimize the operational expense. Capital is only one thing, but managing different manufacturers and different solutions on SAN environments, it literally is like a black art managing a SAN environment sometimes for what you're trying to do. So the idea of how can you reduce and automate stuff at scale applies no matter how large your organization is, no matter how large it is. If you have to go off and jump off to a web interface, a separate application, if it's not automatable, it's not scriptable, you are wasting time and money having to manage that. So I had this little bit of a slide piece inside the first one. I'm going to go through this again for those that weren't there, but basically just demystifying SANs and what they are, or storage in these days and what they are. Doesn't matter the manufacturer, everybody has their different secret sauce for how they implement it. But basically it boils down to these kind of components for what they are. First off, you're going to have x86 or x64 processors running on your compute nodes, your controller nodes that are there. They're going to be running an operating system. That operating system is going to have memory to be able to run. It's going to have memory for cache, and it's going to have all the required drivers to be able to talk to all the different back-end cards and front-end cards and stuff like that. It then is going to have network adapters that your clients can attach up to through a variety of different protocols to be able to have access to those lovely resources of spinning disks that you have. And then finally, it's going to have a back-end way of talking to all those disks and all those enclosures, right? Otherwise, it wouldn't be a storage. It would be a server. So if you kind of draw this out a little bit, what this means is basically if this was your controller, you can kind of break that down into both a front end and a back end. Now on the back end, you're going to have a variety of different ways to attach up to your drive enclosures. You're going to be able to pool your disks together to be able to identify them by characteristic. You're going to be able to lay down different layers of software striping or hardware striping, which is really just software striping, on top of the different systems. You're going to have access to cache in those controllers. You're going to have the ability to set up simples and parities and mirrors and mirrored parities and parity mirrors and all sort of stuff if you wanted to. And then it's going to be obviously talking to a bunch of SAS disks in the back end in your particular enclosure for how you're doing it. However many disks you happen to have is whatever you happen to buy for your capacity. You may or may not be able to extend upon that. On the front end, you're going to have a variety of interfaces on the Ethernet side that you're going to be talking to potentially, or fiber channel side, to be able to offer up iSCSI targets, to be able to offer up fiber channel over Ethernet, to be able to offer up NFS shares or SMB shares, whatever it happens to be. That's simply the front end of what you're talking to. And then finally, if you want to make that highly available, you buy a second or third or fourth controller that's going to go off and manage this as well, and they do their own custom clustering between them to be able to make them highly available. Does this sound familiar to anybody? Lastly, you have your clients, your servers that are going off and talking to that storage back end to be able to have access to systems. Maybe it's through locally through LUNs, maybe it's through different variety of flavors of Ethernet or fiber channel. Whatever it happens to be, basically, you now have your servers consuming all this sort of stuff. And then a new project comes out, and they need to have more IOPS. And you have to go back to your storage manufacturer to say, okay, well, I have this new SAP implementation I want to go ahead and go with. I need to have this many thousand IOPS. And he's like, okay, let's go. Here's another SAN coming in potentially, or whatever it happens to be. So when you look at it from an extensibility perspective, they tend to be rather enclosed and where they work and how they work. If you take a look at Server 2012 with file server, with scale-up file server, and also with storage spaces, we have a similar architecture. We've got disks in the back that are SAS attached. We've got a front end and a back end, if you will. We're able to lay down and group disks into pools of resources that you can then carve out and delegate out for administration and security. We have the ability to present LUNs. We have the ability to present different layers of protection on our disks up to our OS and make them available. We present them with standard iSCSI targets, or we can do it with NFS shares, or we can even do it with SMB3, which is where you get a lot of really cool performance and also benefits by going the SMB3 route instead. And obviously we've been doing clustering for a while now. You want to remember Wolfpack from NT4 days? So we've been doing it for quite some time. And it's the same clustering technology that you've been using all along that we're using for the scale-up file server sort of stuff. We've even made it more automated and more manageable using System Center Virtual Machine Manager. 2012 R2 can actually go in and take an existing file server cluster or in scale-out file server and then say, new node, go. And it can provision from bare bones, as long as it has access to the ILO board or whatever it is you're using to manage that server, to be able to spin that guy up. OS is installed, set him up as a member of the cluster, have him join the cluster, and done. And it rebalances the load across all 3 nodes now. Click of a button. So we've got Server 2012 Spaces as our back end that we're using. We introduced it with 2012, and we added some new functionality with 2012 R2. We then also have our Windows Server 2012 file server, specifically the scale-out file server solution for your applications is the way to go. People ask me, do you use your scale-out file server for your regular Office document shares and stuff? It's like, it's kind of overkill. No, just use a regular clustered file server for that with SMB3 to get phenomenal performance. Scale-up file server is designed to run as an application workload to be able to support VHDX files for virtualization for Hyper-V, and also to support things like SQL databases that support running off of SMB shares. So fantastic stuff. And obviously connectivity-wise for the front end, 1 gig, 10 gig, teamed NICs, RDMA-capable NICs, InfiniBand, Mellanox controllers, ABC123. As long as it's on the hardware list on the front end and your servers can talk to it, boom, you got access to it for where it sits. So from a infrastructure as a service potentially vision for what we're looking at, again, think of yourselves as a service provider providing services to your clients. In this case, it happens to be storage. The idea of trying to drastically lower your costs and your effort of how to deliver that services to your clients. You have to disconnect direct attached storage from individual compute nodes of your server. You do that with a SAN as an example. You can do it with storage spaces in Server 2012 in this thing. The difference is that we're using industry standard hardware, off-the-rack servers with the appropriate pieces added into them if you want to build your own and roll your own. And then we're able to disaggregate or disconnect the compute from the storage by having this. Like literally, I can have multiple Hyper-V nodes with only a locally attached disk to boot up the OS if I wanted to. I can even boot them off of iSCSI Target if I wanted to. But then having them storing all their files up in a shared SMB3 environment that's hosted by a clustered server. We're using commodity disks. We're using commodity JBODs that still are qualified to work with storage spaces, that are still qualified to work with Windows Server 2012 R2, and you got full support for how this thing works across the board. I also recommend, obviously, you get what you pay for, right? You don't expect that a SAN solution is going to match up to a storage spaces solution if you went exactly on everything possibly on the cheap on the Windows Server side of things. You still got to buy quality components. You got to have multiple paths into the JBOD. You got to have multiple paths in the switching environments. You got to basically build this sort of stuff up, but it's still going to come up at a fraction of the cost of what you would expect to pay for a lot of the storage. So from a deployment model, what you would basically have is you'd have shelves of disks on your SAN side with some kind of a storage and compute front end with embedded controller, with their own operating system running on it, basically presenting out the front-end solution to you to connect up to. On our side, we've got our Windows Server file cluster running, scale-out file server. You either manually created it or you had System Center go and create it for you. And then you have a bunch of shared SAS JBODs with a bunch of disks inside of them. As long as they're enterprise-class JBODs, enterprise-class disks, and you've got the switching fabric behind them, you can stack them up side by side from a performance perspective for value for what you can do. You then present out the block level or file level access to the individual shares and to the disks. In this case, we go at SMB3 with file level access to individual VHDX files for virtualization down to your Hyper-V compute nodes. So an example, picture yourself having a big SAN environment, SAN implementation. You've got a bunch of 30 Hyper-V hosts all talking with multiple fiber channel cards to talk to that SAN to get access to their disks. You now want to go and upgrade that, and potentially you now are looking at replacing that SAN. I'm not suggesting you go and throw your SANs out. Don't do that. They still perform. They still do everything you do. They have all the IOPS. They have all the disks. Keep it all in place. I'm just saying, when you look into the next project, the next greenfield implementation, the next expansion you have to do, what you would do is you would simply take the equivalent of those amount of Hyper-V hosts, save yourself $500 to $1,000 a pop just in the fiber channel cards themselves, and just have network connections up to your SMB share for your SMB network to talk to your storage. Just that alone can save you a whole chunk of cash before all the rest of the infrastructure. That's how simple it is to change it over. If we look at comparing them, well, in traditional stuff, you have your storage tiering, fantastic capabilities. You've got data deduplication to save yourself space. You've got resiliency groups that you can make for how you present out that storage. You've got pooling of disks based on capability. If you want to carve off portions of the SAN environment for finance and different portions of it for HR because they paid for it and they want to be able to have their own resources, you can do that. Pooling of disks, high availability with clustering, persistent write-back cache in case you have controller failures, copy offload with ODX copies, snapshots, all that sort of stuff is what you would see in the traditional side. With 2012 R2, the biggest thing that we added with the R2 side is tiering. Phenomenal performance with tiering to be able to set up a storage tier. We have an enhanced version of data deduplication, which allows you to dedupe on the fly with running VMs, for VDI as an example, for massive space savings and even performance gains on stuff. We've made some more resiliency options to be able to make it so that you can have different options for protecting your data. And just trust me, this is not your daddy's version of how you do the old-fashioned mirror disks and stripe disks or RAID disks like you would with NT4 with Disk Mangler to be able to do stuff. This isn't that. It's gotten way bigger and way better than that. We even have some very cool stuff, which I'll talk about in just a bit, about how we rebuild down disks when you replace it. Instead of having a blockade of just having one disk and being able to write to that one, we're able to do a parallel fix on that disk for multiple source streams much, much faster. Continuous availability with clustering, persistent write-back cache was also added with how that works in write-back cache. I'll show you that, or just talk about it. We've got copy offloads with already made controllers. We also have snapshots, so it's all there. But the biggest change that we introduced was this little puppy right here, tiering. The idea with tiering is that literally you take, let's say, a very small JBOD of 12 drives. You use 8 drives as your traditional spindle drives, and you buy 4 enterprise-grade SSDs. You put them inside that drive enclosure, you select them all, and you say new pool of disks in Server 2012 R2. Once you've done that, you then go in and you lay down your parity information for striping or your mirrored information to basically protect those drives with virtual disks. Once you've done that, you're able to go and identify if they're going to be either a hot tier or a cold tier, and you get to allocate how much space you want to have allocated to them. You can see upwards of 16 times performance increase by doing this, because what we do is we actually move and track heat for access on that tier from this point forward, and a scheduled task runs at 1 o'clock to analyze that heat of what blocks of data are being used on that tier that's on cold, and basically on a scheduled task at 1 a.m., move those blocks over to the SSD tier. Any blocks that are no longer hot that were on the SSD tier move off to the HDD tier. And this dynamically runs every day at 1 o'clock to be able to move the blocks. And the files can be open and running while this is going on, completely transparent to the OS and to the servers that are running and accessing these different systems. That's as simple as it gets. In case you're wondering how big the size are, we go with 1 meg size, so it's not too big and not too small, to be able to do this particular move. So we track the heat of 1 meg chunks of files. We don't want to randomize too much, and basically it's a scheduled task. I'm surprised no one's asked me yet, but you can schedule this to occur at different times. You can kick it off manually if you want to. You don't have to wait for it to take place at 1 o'clock. And you can also be smarter than the OS and pin your own file in its entirety up to the higher tier if you want to. I want to show you a demonstration of pinning some stuff because I don't particularly feel like waiting around here with you guys until 1 a.m. to see my demos work. when it rebalances. Now, when you pin it, it is stuck there, just so you know. So be careful when you pin stuff for what it is that you're doing. You're more than likely going to be pinning your stuff in an environment where you have a gold VDI image, as an example, of the main OS, differentials off of that. You'd pin that first one on the tier. My first question, sir. Yes, sir.
Can you PowerShell to pin the data? So, for example, if you run a report in like month in, it will move into the gold drive. So it won't hot tier the schedule be slow to run.
Can you use PowerShell to be able to pin the data and then get programmatic with how you analyze the data to be able to choose what gets pinned and do it on a monthly cycle as opposed to a daily cycle? Sky's the limit. Absolutely. I'm going to actually be showing you my demo all in PowerShell to be able to show you how to do this. Besides, the GUI interface is just too simple to look at, so I want to raise the level. Like right now, this is a 200 level. I'm going to simultaneously raise this to a 500 level session with my PowerShell stuff. I'll show you in just a minute. So if you need to leave the room, I understand. You know what? Actually, I'm talking about this too much. So let's actually just dive right in here. I'm going to show you this. I'll switch it over in just 1 second. I got to make sure I can log in correctly. And everything's good to go. Hit my special button. And we got it. This is for what, One Tree Hill or something like that? Some park around here? I got to go find that. That looks too awesome. How many what? Oh, good question. Not about the picture, but about something else. The question is, how many tiers can you do? Very good question. 1 tier. We do not differentiate between speed of spindle. Basically, if it has a spindle, it's slow. I don't care if it's 15,000 RPM or if it's 7,200 RPM or whatever, it's slow. SSD, no spindle, phenomenally fast. That's your hot tier. So basically, you have 2 tiers and that's it, hot and cold for what it is. Okay, so how many people here have JBODs with enterprise class grade SSDs and HDDs they can go off and play with tiering? Anybody? I see 1, 2, 3, maybe 10 people in the room. Everybody else, this demo's for you. What I'm going to show you is actually from a blog post from a good friend of mine, Jose Barreto. He's on the file server team, and he wrote a beautifully detailed blog post about how to go ahead and to demonstrate tiering on commodity hardware to the point where it's actually just my laptop with an HDD and an SDD on it to simulate tiering to be able to see this work. So you'll be able to reproduce this entire demo on whatever hardware you have on your systems. So this is a gift for you to take with you. I give you all 175 lines of this code in the slides you can download and take a look at afterwards. A little bit of prep work. I also obviously referenced his blog post because it's an awesome blog post. But to speed things up right here, I've already gone ahead and basically created a fixed disk size, 4 drives that are 10 gigs in size, and below that, 8 drives that are 30 gigs in size as well. So I've gone ahead and pre-created those. To show you that, on my external drive right here is my slow tier, and I have drives 1 through 8 already created, disks 1 through 8. On my second drive, which is on here, I have a bunch of ones, but these are the ones I care about right here, which are my SSD simulation. That's there. Before I continue any further, I need everyone to repeat after me. I promise, come on, I will not do this in production. This is unsupported. Okay, you've all been warned. Storage pools and storage tiering is not supported in a virtualized environment. Inside the guests, I'm using it to be able to abstract it and show you, follow where I'm going. I basically created some SSDs and HDD VHDX files on the appropriate media. D drive is my SDD, F drive is my HDD right here. Hopefully it doesn't fall over. I've gone ahead and created a VM that's called Domain Controller, or DC, that's already up and running. And right now what I'm going to do is I'm going to add these disks into this VM. As you can see here, I currently have no SCSI disks. By using that line of code and running it. And then when it comes back, go ahead and use this line of code to be able to add the HDDs. And you should see, without the lights blinding you, the little blinky light saying stuff's going on. And when it gives me control again, I know that I've completed that particular task. If I actually had to create these, I have the commands to be able to create them. It would take about an hour and a half or so to be able to make those disks because it's a full fixed disk in size. Once that's now done, just to be able to prove to you that's all finished, I go in and take a look at the settings, and I can now see that all my drives have now been added as drives inside my virtualized environment. Going back to my PowerShell, I'm just going to go ahead and start that guy up. Let him boot, percolate a little bit, realize some new hardware changed, and then we'll jump back into the PowerShell inside that VM in just a minute. The idea with going to this, in case people are wondering, the cost-benefit ratio that we've done for calculations on cost of drives and IOPS and that sort of stuff, for a 12 drive, for a 60 drive enclosure, let's say. A 60 drive enclosure, your sweet spot is anywhere between 4 to 12 SSDs inside of a 60 enclosure JBOD to be able to get the optimal density, so size, versus IOPS, speed increase. If you go more SSDs, it becomes too expensive. If you go less SSDs, you don't get as much performance. The reason why we also went with 7200 is the recommended size, just because for the amount you pay for a 15,000 RPM SAS drive is not equivalent to what you would get for performance for IOPS compared to spending the extra money to get an SSD. And plus SSDs are coming down in price. So again, this particular environment that I've got set up right now is my laptop. But generally speaking, you can get great performance for density, dollar-wise, dollar value, going with 7200 RPM drives that are SAS drives, 3 terabyte drives, let's say, and then 4 to 12 SSDs on that particular configuration. Yep?
Can you mix like the PCIe SSDs and the traditional disk SSDs?
Okay, the question is, can you mix PCIe SSDs and other SSDs, like traditional SSDs? The answer is, we don't care. Obviously, you're going to get different performance if you use the PCI ones. Like there was a demo of the guys from the Fusion I/O cards in TechEd Australia. They had a beautiful Fusion I/O card inside an HP microserver with 4 traditional spindle disks. Wicked, absolutely wicked demo that they were using, and they wouldn't let me take it, unfortunately. But yeah, I would tend to say you're going to want to stick with what you have. You're not going to want to mix and match, just as a rule of thumb, for where things are. Now, I got my resolutions wrong, so hang on a second here while I change my resolutions on this guy, because it is way too big. I think we'll have to go and get him down. Oh, love this, eh? That's what happens when you prepare for a different resolution. There, now we can see everything all on one page, one screen. Okay. So, here's the continuation of where we left off. On my C drive, I've got my scripts directory. And scrolling down, I'm going to have to reduce the resolution on this so you can see it a bit better. There we go. So I've gone ahead and I've added the drives, I've started the VM. And in case you guys are interested, let's verify to make sure that all these disks are ready to go and be used inside of a pool. So this is going to simply run a PowerShell command, list off all the disks, sort by size, and you can see here that some of them are available to be used in the pool with true, one of them is not. That's because it's currently the OS drive, and it will not fit. But I definitely have 2 different size drives available inside my environment. I want to go off and simply list off all the SSD drives, which are basically my smaller ones. Oops. Of course, I ran the wrong command. Stop. There we go. See how badly I just did on that guy there. F8 to run that guy. Come on. Oh, great. It went ahead and already did those commands for me. So, the best part about this is I can go through. He's good. He's fine. Storage manager to see if there's been too much progress on this guy as of yet. And see if I've gone ahead and made my pool, which is the main thing. Okay. Some there, some there. Okay. So let me back up in my script because I hit the wrong button. I'll tell you where I'm at right now. So basically I've gone ahead and I've created a pool. This guy here goes ahead and simply lists off all the small drives. This guy here goes off and lists off all the big drives. Right there. Next guy up basically goes ahead and sets the storage subsystem to be used and create a new pool called Pool 1 of all available disks. And then I'm going to go ahead and see, did it already classify my disks as of yet? Yes. Okay, there we go. So what I have to do is when you bring these disks into the system, if I scroll down here to pools for all of my disks, you'll notice that I've got different size ones. If I choose by capacity, I've got both basically 10 gig and 30 gigs. And then if I scroll over all the way up here, I've got them all listed as SSD because it's virtualized. It thinks they're all SSD, so it's just going to classify them. You don't get the ability to change the media type until they join into a pool if you want to manually write it. So basically, I'm overriding what they really are by changing a property called media type. You can't do that until they already have joined themselves into a pool. So I've gone ahead and basically ran this command here that says list off all the disks that are less than 20 gigabytes, set them, fake them out as being SSD. Do the same thing over here to be able to list them out. And basically anything larger than 20 gigabytes, go ahead and set them up as a fake out of HDD. Going back to this guy here, hitting a refresh, I now will see that my media types should now represent both SSD and HDD on my system. There we go. Everybody see here? I've got both SSD and HDD listed. Again, I have the same characteristics of what you would expect because my virtual disks that are smaller are on my SSD drive, and my virtual disks that are larger are on my HDD drive up here. They appeared all as one common type, which won't work for tiering, so I manually overrode that to say, no, these guys are really SSDs, classify them as that. These guys are HDDs, classify them as that. That's the non-supported part, in case you're wondering, for what's going on. Okay, storage pool's been made. Let's go in and just double check to make sure that it all worked correctly. We can now see that the pool has been created. It's all healthy. And if I go ahead and sort disks by size, I can see that I have all my disks are now healthy. And if I want to go in and sort my disks by media type, I can now list them off that some of them are SSD and some of them are HDD. So we're on the right track to be able to do this. So now it's about doing the tiering. First off here, it says go ahead and make a new tier. We're going to call this tier SSD tier, and it's going to be all the drives that are media type of SSD. That's the first tier being made. Do the same thing for HDD. Okay, there it gets made as well. And then go ahead and check the configuration to make sure that guy worked. I should have two drives. Yes, SSD tier and HDD tier. All this in PowerShell, in case you're wondering, still hasn't shown anything up in my storage side of things for managing storage. I don't have any disks made as of yet. All I've done is simply classify the media and made it available. Okay, so let's go ahead and make some resiliency to make it visible. So what I'm going to do is I'm going to make a new storage group that basically is going to be called simple for the way that we're doing our resiliency on that particular drive set. We're going to make one simple set, and we're going to go ahead and make one mirrored set. So basically our protection level for resiliency is going to be mirror set. And then finally, let's go ahead and create the spaces to go along with it. So here's the first line that basically goes in and says, make myself a new virtual disk called space 1. It's going to be simple, and it's going to be comprised of both SSD and HDD systems. I'm going to have 8 gigabytes for my hot. I'm going to have 32 gigabytes for my cold, and a write-back cache of 1 gig. That's what that line of command does. It goes ahead and makes my first one. Next up, go ahead and do the same thing, but this time do it for my mirrored space as well. Goes ahead, makes it for my mirrored space, comes back. Then we have actually making it so it's visible, because if I still look here and do a refresh, I still can't really see anything yet for as far as virtual disks are concerned. Oh, there they are. Volumes, I meant to say. I don't have any volumes yet. So I now have a mirrored space and a simple space ready to go. So let's go ahead and actually get a volume on this we can actually start to use. To make sure that this works correctly timing-wise, I need to do each line individually. So basically, making sure that the disk is set for read-only. Go ahead and make sure it's offline. Go ahead and initialize the disk with a GPT table. Go down here and then make a new partition. And then F drive, finally go ahead and initialize the file system. I now have an F drive that is set up as space number 1, which is my simple configuration. Number 2, do the exact same thing so I can show you both performance data on both of them. It went a bit too fast on that guy there. Okay, he's already run. And then finally, get him initialized. There we go. Finishes off the format, and now it comes down. Back to the GUI interface. If I scroll up, I now have, under volumes, a refresh. Something that we all understand with the GUI interface now. I've got an F drive and a G drive that is now set up as a tier and available with total storage space of 40 gigabytes in size. So now, for the real fun stuff, let's go ahead and create 3 different test files. The first test file is going to be set up on one tier. The second test file is going to be on a different tier. The third test file doesn't care. It's going to be on whatever tier it wants. So basically, I just made a couple of quick DAT files, 4 gigs in size. And I want to basically set file number 1 to be on the Space 1 SDD tier, so the fast one. I want to do, this is basically what I'm doing is I'm pinning the file. I want to pin this file over to the HDD tier. I then want to go ahead and basically check to make sure everything is good. You can see here that it just so happens file 1 is already on the SSD tier. It's all set to go. File number 2 is currently on the SSD and has to be moved to the HDD from a pinning perspective. And I'll just go ahead and repeat the same steps on my G drive. There's my sample files. Here's me pinning the first file. Here's me pinning the second file. And then here's me just giving an example to view to make sure it's all done. Recap. What have I done? I've made 12 drive configuration. 8 of them are HDD on the external drive, completely unsupported, just there for demo purposes. 4 of them are on my SSD drive, which is on my local machine. Basically, D is SSD and F is the spindles. I've gone ahead and basically established and created a space, a pool. I've created a space. I've established a hot and a cold tier, and I've associated the appropriate drives to be the hot and cold tiers, and I've gone ahead and made some demo data on that system. Can you see why I said I jumped this up to a 500 level with PowerShell? And you're lucky I'm not typing all of this, because I would completely flub that up. Okay, so if I go ahead, I already know that they're all there. So let's go ahead and I'll show you these scheduled tasks. So we use, as I mentioned, scheduled tasks that run at 1 a.m. to be able to basically analyze the hot data throughout the last day to tell me what blocks are in use. And I also, that's called the management initialization. And then the optimization task is the one that actually moves the blocks of data in 1 meg chunks to the appropriate tiers on and off. And as you can see, it actually is a scheduled task, and I can actually look at the scheduled task, and it's set to run at 1 a.m. Pretty simple stuff. So let's go ahead and manually kick these guys off, because I don't think you guys want to wait around until 1 a.m. This one here is going to go ahead and basically start the scheduled task to move the optimization. We don't have to worry about the analysis because I've pinned stuff there. So I'm going to let that guy go off and run. I have to talk for a little bit as my blinky light over here, which you can just barely see probably because the lights that are on the stage, is currently flashing madly because it's trying to copy some of those sample data files off of the SSD onto the HDD. And I can't continue until this guy stops flashing. If my memory serves me correctly, it takes about a minute to go, so I can take a question while I'm waiting, if anyone's interested in a question. Everyone's still awake, I hope, because this is a riveting PowerShell demo I'm showing you right now. There's a brave gentleman right there. Yes, sir. No maple syrup this year. Nice. I do have maple syrup, and I am giving out maple syrup for questions, but I'm saving that for tomorrow. Tomorrow is going to be I'm going to be going through 2 sessions with upgrading your infrastructure from 2003, 2008, 2008 R2 up to 2012. I've got 2 sessions with Maca, and that's where the maple syrup comes out. Good question. The question is, how do you define an SSD as enterprise grade level? Well, SAS SSDs, and you get what you pay for. How's that? If it's on the hardware compatibility list for the particular JBOD enclosure, you're good to go. Again, would not recommend you use consumer grade Dick Smith special $399 or $800 SSD inside your environment because, again, you get what you pay for. You'll burn it out, basically, before it's good. Okay, my drive has stopped flashing here, so that means I can go ahead and see if it's all good to go. This guy here is now done. Hit the F8 to see. Yeah, basically it ran. Still scheduled to go. And then here, let's go off and take a look at the F drive. So on the F drive, you can see completely on tier. So I have properly number 1 on the SSD, number 2 on the HDD, number 3 I don't care. It's just going to land wherever it happens to land for the first set of drives that I've configured. So I'm going to use SQL I/O to go ahead and to simulate some 30 seconds of random traffic, random 8K reads basically, against file number 1. It's going to come back with a response to see what it comes back with. Now remember the IOs per second. This tiering is supposed to give you a massive amount of increase on IOs per second over your traditional spindles that are out there. And if we did our work correctly, because we pin stuff rather than let it happen automatically, we should get some pretty phenomenal results because this is coming off of an SSD. Mind you, it is one of those Dick Smith drives that I have in here. So, just so you know, it will be quite good. Any guesses on how much it's going to be? Anybody? IOs per second? Random 8K reads across a 4 gig file? 43,000, 42,000? You guys are too good. 43,000 IOPS per second by having a consumer grade SSD inside of my laptop for this particular demo. Okay, let's see how that performs on a HDD tier. Any guesses before it gets to the answer in 30 seconds? 120. Someone says 120, 180. My money's on, I'm going to say around 111 IOPS. So I did this last night. But it's random, you never know. So it may come off more, may come off less. Come on, baby. What do we got? 3 IOPS. There we go. 114.5 IOPS. By simply inserting a couple of SSDs into your JBOD device using Server 2012 R2 with tiering and then making your storage in this kind of a fashion without pinning, eventually all the stuff you need to have access to will move itself to the hot tier. Obviously your results may vary, your mileage may vary based on your hardware and what you're trying to do, but it's a dramatic increase at a fraction of a cost of implementing a whole new solution. In the interest of time, because there is less time, I'll just let you know that we also do sequentials as well. I'm not going to bother running these particular tests. You have the access to the scripts to be able to write them yourself. You could run this on non-virtualized hardware. You could run this on physical hardware. It's very well laid out, beautiful to be able to see these kind of results and take a look at it. And I gave it to you as a gift inside the slides to reproduce yourself. That's my massive demo. Okay, now back to the architectural discussions that we have for this. Storage tiering is one thing I wanted to show you, but how about some actual proof points for people using this inside production? Because obviously looking at a laptop with a couple of drives does not do this justice in the slightest. I don't know if you guys have heard of the Windows team before. You know, they write this operating system called Windows. They produce a massive amount of data, and they're a team within Microsoft, and they're an internal customer of ours that basically the Windows release team used storage spaces to be able to handle some of the issues that they had during the development process. They're basically responsible for managing the building of symbols. You guys know symbol data when it comes time for troubleshooting and stuff like that? Across the entire Windows team. Every single team has their own source codes that they use, their own repositories and different sub-repositories and their own SAN environments, and trying to coordinate how this goes across the board is rather tricky. So their problems are along the lines of sheer volume and size for capacity, because they have to maintain different versions of different builds of the different symbols to be able to do bug tracking against them. And their existing environment was around 2 petabytes of data that was going through this type of environment. And even with 2 petabytes worth of data, they could only save 5 days worth of work. That's how massive the amount of change is going on inside their environment for daily builds for all the different teams. So basically, when they came time to expand upon it, it was like going to be extremely complex and also impractical because they're trying to figure out across the variety of mixes of direct attached storages, of various different vendors of SANs and different types of servers and all sort of stuff. There's no way also to determine if it was properly set up for highly availability because everybody had their own solution for what they're trying to do. So they wanted to change from a 5-day retention up to a 30-day retention of data. Think of the numbers, 30 days of data on that system. They also need to be able to scale the platform in the future, while also obviously not breaking the bank for trying to drive a lower cost per terabyte that's out there. So with the way that they've implemented storage spaces with Server 2012 and 2012 R2 is basically they had a 2 times increase in total storage throughput to have access to things. In fact, they had so much throughput that they crushed the network. The network was the bottleneck all of a sudden to get access to all this data. They had to actually go in and update the switching infrastructure to be able to match the client demand of having access to all this data that was out there. So it would spill over to other buildings on the campus because it's a mesh network that we use on campus. So it's rather big. It's across different buildings. We had a 3 times increase in raw capacity for the existing same storage budget because they reduced the number of servers, they've simplified the number of connections, they've also gone ahead with a much more dense implementation that they were there. So basically the cost per terabyte went from $1,300 per terabyte down to $450 per terabyte in storage costs for their budget. 5 times increase in capacity for deduplication as well because it's now inside one spot, so deduplication can also give them a good savings and stuff. And in fact, with all of that, they're able to handle easily 30 days worth of stuff. And a 6-time reduction in the number of servers. Picture yourself managing a server room, and then all of a sudden, after this project is implemented, removing 8 full 42U racks worth of drives and servers out, and basically having this new solution that's now scalable and working. No more power, no more cooling, no more space requirements now. 8 full 42 racks of systems to be able to support this, and they are now able to do a 6 times reduction in the number of servers. Phenomenal stories. It's awesome. Here's what it looked like. Basically, 20 servers with 20 60-bay JBODs used for spaces that are all interconnected with 10 gig Ethernet amongst them. It's now connected up to other buildings on campus with a mesh 80 gigabit network that's on there. It basically goes through, and actually this particular environment here with this particular solution, 20 servers with 10 gig E, 20 60-bay JBODs with 3 terabyte 3200 RPM HDDs, can easily double in size if they needed to, can handle 720 petabytes of weekly data volume flowing through this. So I don't know if you guys have the same level of load that's required to be able to get through this, but I think this is enterprise grade for what we're doing with commodity hardware on the HCL, enterprise class JBODs and switches. I'm not saying this is cheap. It's just cheaper than the existing solutions they were using and also cheaper than other growth solutions that they were looking at going to. So basically storage spaces, how does this actually work from a component perspective? You've got shared SAS JBOD arrays with enterprise-grade redundancy that can be built in. Dual-port shared SAS connectors on the back end of those guys that you're doing this. You obviously have to make sure in the clustered environment that you have access to all the shared disk between all the nodes of that particular scale-up file server cluster. But then what the interesting thing is that you don't have to have, that's not 20 nodes in a cluster for scale-up file server. That's groupings of scale-up file server clusters with an abstracted namespace to make it look like it's all one, to be able to handle that for how it's set up. Redundant power connections, redundant SAS controllers. It even has little blinky LED light capability to identify the drives that have failed to get them replaced if you need to pull the drive to make it continue to work. Some capabilities, some ideas for how this basically was working. They would go ahead and create pools to aggregate disks. Basically, that's your management point to be able to do it as your storage pool. You then go ahead and with resilient storage spaces, you lay down your individual protection mechanisms that you want to have. On top of that, either mirrored or parity. It has data striping that takes place across the different disks. When a particular disk happens to fail, before we get there, actually, when doing data copies back and forth. Enclosures are also aware if they're certified spaces hardware. When I go in and make a mirrored space, and it happens to be across 2 enclosures, it's going to try to put the data across both of those enclosures. So you actually can protect yourself against an enclosure having issues as well. In this case, in a lab environment, when we have a problem with a drive that dies, in the past, you would have, the hot spare would have to kick in, and basically you'd have to rebuild that one guy from one source, which is not terribly effective. What we do is we actually do a parallel rebuild from the different sources where that data is located across the different systems. And you can actually get throughput-wise. We had 8 3 terabyte drives in a particular disk space. One drive failed with 2.4 terabytes worth of data on that one drive. It was rebuilt in parallel from all the other sources that were available and was online again in 48 minutes. 2.4 terabytes of down data, new drive swapped in, up and running again, fully functional in 48 minutes. That's about 800 megabytes per second, which is far beyond a single bottleneck of a drive that's going on for throughput to go through. We have a periodic data integrity scanner that basically runs in the background with both NTFS and REFS to be able to make sure that the metadata with the different blocks of data on the drive are good, and basically can fix where possible for corruptions. We have basically the ability to go off and to manage it. I showed you the management with 170 odd lines of, it's not really 170, it's probably about 50 odd lines of PowerShell, fully documented in case you want to take a look at it, to be able to make a space, pin a file, move it, schedule it, and all sort of stuff, all for you to be able to take a look at. Or you can use Server Manager, or the best solution at scale is Virtual Machine Manager 2012 R2, where you can go ahead and dynamically deploy new scale-out file servers and add new nodes to the system as required on the system. Some deployment recommendations. People ask me, what type of formatting do you recommend for different types of workloads? So basically, if you're going with, in this case we're using mirrored, we go either two-way or three-way. That is going to be your best performing laydown of protection of resiliency for your buck that you can get, although there is a higher quote-unquote tax because you have to have more drives. That's going to give you your best throughput to your system. Second up to that is going to be your parity solution. Think of it like RAID, but it's not really RAID. RAID's at a disk level. In this case, we have single parity and dual parity with R2. We only had single parity before with 2012. With 2012 R2, we introduced dual parity. That's better for sequential workloads, archival, massive data storage, where you have to worry about not so much for performance, but just simply for sheer volume. And finally, simple, which I don't personally recommend, because I know as soon as the drive fails, basically you're SOL. There is no protection to it whatsoever, but that basically is simply for super fast workloads that do not require resiliency whatsoever, and you have to provide some other level of resiliency to the system. So bundling this together, I'm just going to build these slides out because I'm running short on time. I want to give a chance for a couple of questions that are there. Spaces in Windows file server clusters, if you build this sort of stuff out, you're starting off with two 60-bay JBODs talking to both servers simultaneously through shared SAS backplane and multiple SAS connections, one per server into each of those boxes. You're looking at about 96 gigabits per second shared SAS link to those 60 drives that now those two nodes, the scale of file server, have access to. And then you have the scale of file server UNC name being shared out as the abstraction for which server actually holds that data, because they both have access to it. Scale that out even more to, in this case, 4 nodes, and you're simply adding more drives and more JBODs and more complexity, more SAS cables, more network connection, more cost, but still at a fraction of the cost which you'd expect for a traditional enterprise SAN type of solution that's out there. You can then even go even further and have these groups of clusters abstracted amongst each other as well for massive amounts of storage by having a unified namespace with clustered shared volumes across your systems. So this actually goes and spans, in this case, 1 petabyte per implementation, 768 gigabits per second shared SAS links down to those guys across 4 different servers with 10 gig Ethernet. We're talking freaking bandwidth here, freaking storage here. Absolutely amazing stuff. With storage spaces as an example, this one particular quote was from Philip Moss. You guys can read it. Hyper-V over SMB and other new features. I have eliminated big, lumpy capital expenditures. I like those. Big, lumpy capital expenditures. And then from the Windows team, Jeremy Russell came back and basically using commodity hardware to achieve the same functionality of traditional storage at a far, far lower cost for what's there. Being mindful of time, seeing what's left for what's up there. We've got the dual parity as one option for one particular way of protecting your data that's on your system, which basically is 2 possible disk failures that can now go bad in your parity workload. Very efficient rebuild times because of parallel processing. It's supported with clustering, and it also supports journaling for power fault resiliency as well. And then this concept of how we move the stuff around, think of it like this. Basically, your common workload characteristics of a very large data set of the stuff that you're looking at, but in actual fact, the majority of that data is cold or older. You don't need to have access to it. There's a smaller amount that has a working set that can possibly move potentially, and the hot data of that working set basically changes over time. And that's why we do a scheduled analysis every day to see what is useful and not useful, or you can manually kick it off. We went with 7200 RPM drives for your best capacity, and then you went with solid state drives for your best performance. And then you mix and match those inside your environments to make them fit. What I wanted to share with you as well, just to kind of get this guy set to go, was something that Jeff Alexander is going to be going into some more detail in his session, which is this concept of, which is also new in 2012, is this concept of write-back cache. So typically you would have a cache controller that would basically have a battery backup to basically have a set of cache. You could be persistent in case there was a power outage, you wouldn't lose that data. But also the cache would be able to serve up responses faster and handle those blurts or those bubbles of performance issues. We've implemented that as well. And what we've done is we basically, when you make a tier and you enable write-back cache, we reserve a small portion of that hot tier for this persistent storage. And with that, you basically are able to handle the unexpected random workload that might hit your constant workload and bring performance down. I encourage you to come and check out Jeff's session coming up on overall overview of storage changes. He's got some great demos to show you how that works and some real life numbers of showing you performance graphs and stuff like that of how that goes across the write-back cache. Very, very cool stuff of how that works. By default, we allocate, in this case, it was a gig that happens to be there. You are able to set the level that you want to set and comfortable with for your particular resources on your system. So the idea with the file server cluster configuration is that you can either go and optimize for capacity to basically have your best dollars per terabyte, very, very large drives, slower spinning drives, more drives to get more capacity, very cost efficient. You have extreme performance optimized systems that basically have the highest throughput IOPS. As I mentioned, it doesn't have to be SSD. It could be the Fusion IO cards as an example, or other manufacturers that are the PCIe drives that are out there because they show themselves as individual drives. You then have a balanced approach with tiered storage to fit all these guys together inside your best IOPS per dollar and best performance per dollar that happens to be inside your environment. Some examples of some file server cluster solution partners that are out there. I'm a big fan of Data On myself. They're an OEM manufacturer that's new in the market space for doing storage stuff. They do traditional storage servers. My back-end servers that I was doing some demos off of earlier in my session is running a Data On configuration, and it is 8 drives that are spindle, 7200 RPM, 3 terabyte drives, and then I've got 4 SSD, enterprise-grade SSDs inside there as well. The performance numbers on that are phenomenal compared to that little quick demo I did here on my laptop. And then the thing I like about that as a cluster-in-a-box solution is it's one piece of tin, no external cables, and it's a full 2-node cluster with 12 drives, and the ability to plug in another external JBOD off of that to be able to have a nice little compute node, highly available, and lots of drives built into it. Very, very good stuff where that fits. Some takeaways that I want to leave you with before I take a couple of questions before I wrap this guy up. Server 2012 basically is a great component into your public and private cloud. Think of it as a new building block for how you look at this. As I mentioned earlier, I'm not advocating you throw away your SANs. Don't do that. You've bought them, you use them, they got phenomenal IOPS, they are designed for the solution, you've implemented them. What I'm asking you to do is simply look at this from a net new project, net new expansion, and also possibly lab environments. They are definitely production ready, as you saw from the Windows build team, for what we do from sheer size and volume. So when you're ready for the scale, we're ready for you. And think of the amount of change that we just invested in going from 2012 with introducing spaces, now having tiering in 2012 R2. And it's all of our learnings that we've learned from working in the public cloud and bringing that into our private cloud solutions that you can now use today. My demo rig up here is a very simple, off-the-shelf Lenovo 530, W530 ThinkPad style laptop. And I have a secondary hard drive built in, which is my SSD for my VMs. And I've got a generic, you plug them, buy them at Dick Smith's toolless drive enclosure for my HDD tier. You can reproduce my demos that I did on similar hardware, or you can actually do it on real hardware if you have access to it to see what I mean from a difference of performance and IOPS. Now, especially that you've got the release code, RTM access on TechNet and MSDN, but I did all this stuff using preview bits to work in preview. Again, massive increase in throughput, massive reduction in capital expenditure. 8 42U racks have moved on to other projects. The savings in power and cooling and storage and maintenance alone is astronomical, having 8 42U racks moved out and now increasing the capabilities of what happens to be there. So my bonus material that I gave you, just to prove to you it's here, it's basically how to build your own storage tiering demo. And what I've done is I've actually given you all the slides in chunks of what was accomplished. with all the appropriate connections that are on there. Some words of advice, obviously, do not do this in production. You all said you wouldn't, and you all took the promise and the oath. This is just for demo purposes. But we also have the ability to go through and run this on your own real hardware if you wanted to. And I've tried my best to try to group it into individual chunks of what I'm trying to do in that PowerShell code. I can't take credit for the PowerShell code. That goes entirely to Jose Barreto's blog post, which I reference at the top of that code in the slides. I encourage you to go off and read that blog post. He's got some phenomenal stuff that's in there. And it goes through making the tiers, running the jobs, running the actual tests on your systems. And with that, I'm going to say, don't forget your evaluations, please, for this particular session. I hope you enjoyed this deeper dive in storage spaces. My name's Rick Claus, aka MS/TE, to kick off those evals. Please let us know how I did and what I could do better and how I can improve for the session. I hope you enjoyed it. In the interest of time and being respectful to the speakers, I'm just going to take some questions down front here. I'll be around the event hall. If you want to talk to me all day today and tomorrow, just look for the green hat. And I think I even have a slide on that. No, I don't. Okay.